Solve the following equations and check for extraneous solutions. So when we solve rational equations, the first thing that we need to do is figure out what values of x do we need to exclude. So we set each denominator equal to 0. So we have 2x plus 1 equals 0. Subtract 1. 2x equals negative 1, divide by 2. So we have x cannot equal 1/2, except if x equals negative 1/2, then we're dividing by 0. And the same thing for 4x plus 3. Set that denominator equal to 0. Subtract 3 and divide by 4. We get x cannot equal negative 3/4. So those cannot be the solution. Those two values of x are not possible solutions for this equation. So when we solve rational equations, we want to have the common denominator on both sides. Once we have a common denominator, we equate the numerators. So the common denominator here is 2x plus 1 times 4x plus 3. So this rational expression over here is missing the 4x plus 3. So I'm going to multiply this rational expression by 1, but I'm going to make my 1 4x plus 3 over 4x plus 3 equals 5 divided by 4x plus 3, and this expression is missing a factor of 2x plus 3 in the denominator. 2x plus 1 in the denominator, not 2x plus 3, 2x plus 1. So, now that I have a common denominator on both sides of this equation, I equate the numerators. I say I'm going to set the numerators equal to each other. I'm going to set the numerators equal to each other here. So this gives me 3 times 4x plus 3 equals 5 times 2x plus 1. This is a nice Algebra 1 equation now that I just have to distribute. 12x plus 9 equals 10x plus 5. This is, now we get the x's on one side of the equation and get the numbers on the other side. So minus 10x, minus 10x, minus 9, minus 9. So I have 2x equals negative 4, so x equals negative 2. X equals negative 2 is our solution, but we have to go back and check. Did we have to throw that out because that would cause me to divide by 0? And the answer is no, so there are no extraneous solutions. There are none, so the only solution is x equals negative 2. Number 2, 7 divided by b plus 3 plus 5 divided by b minus 3 equals 10b minus 2 over b squared minus 9. So the first thing I saw was that b squared minus 9 is the difference of perfect squares, so I'm going to factor that, because I'm going to need a common denominator to solve this rational equation. And luckily, the common denominator is b plus 3 times b minus 3. So this rational expression doesn't need anything. This rational expression needs a factor of b plus 3, and this first rational expression needs a factor of b minus 3. But before we go on and finish solving this, let's figure out what values of b we need to throw out. We need to throw out negative 3, because if I plug in a negative 3 there, I would get 0. We need to throw out b equals 3, so b cannot equal 3, because that would cause me to divide by 0 here. And for this expression, negative 3 and 3 have that covered. So if I get a solution of negative 3 or 3, we call it an extraneous solution and don't include it in the solution set. So let's get our common denominators. I need a factor of b minus 3, so I'm going to multiply by 1, but that 1 is going to be b minus 3 divided by b minus 3. Plus, well, this rational expression needs a factor of b plus 3 to get the common denominator. And on this side, I don't need to do anything because it already has the common denominator. And once a rational equation has a common denominator, we also know that the numerators must be equal, so we equate the numerators. So we have 7 times b minus 3 plus 5 times b plus 3 equals 10b minus 2. So 7b minus 21 plus 5b plus 15 equals 10b minus 2. Can I combine like terms on the left side? 12 minus 6 equals 10b minus 2. 12b that is. Subtract 10b, 2b minus 6 equals negative 2. Add 6 and get 2b equals 4, so b equals 2. Again, notice that it's not one of my two values that I excluded, so there's no extraneous solutions, and b equals 2 is our final answer. B equals 2 is the value that when I plug it in, I get a true statement. Number 3, 4 divided by x minus 1 minus 3 equals negative 3 over x. So first of all, I'm going to take that 3 and put it over 1, just so I can see everything as a fraction. The common denominator that I need is x, because that's really like x plus 0, times x minus 1. I need a factor of x, and I need a factor of x minus 1. What values do I need to throw out? I need to get rid of x. I need to exclude x equals 1, so x cannot be 1. That will never be 0. And I need to exclude x equals 0, so x cannot equal 0. If I get those two, I need to throw that solution out because those solutions would be called extraneous. So this first expression is missing a factor of x. This second expression is missing both factors, so it needs an x times x plus 1 over x times x plus 1 equals negative 3. I'm going to move that negative 3 up with the negative 3. Negative 3 over x, and it needs a factor of x minus 1. I don't know why that became x plus 1 there. Minus 1. So now that I have a common denominator, we equate the numerators. 4x minus 3x times x minus 1 equals negative 3 times x minus 1. Let's distribute. 4x, I'm going to distribute a negative 3x in, so minus 3x squared plus 3x equals negative 3x plus 3. So this is a quadratic equation, so I'm going to set it equal to 0 and then factor. I like having a positive x squared, so I'm going to move everything to the other side after I combine like terms. So I'm going to move everything over to the right side, so plus 3x squared minus 7x minus 7x. So 0 equals 3x squared minus 10x plus 3. So whenever we solve a quadratic equation or any polynomial equation, we want it set equal to 0. Now we factor. And this is a trinomial, so I'm going to have to use the AC method. What multiplies to a times c? What multiplies to 9? That adds to negative 10. Well, that's negative 9 and negative 1. So I'm going to break up that middle term using those two numbers. And now GCF. Now group, because it's 4 terms, I can group. X minus 3. I'm going to have to take out a negative 1. So I get 0 equals, in factored form, x minus 3 times 3x minus 1. Now I can apply the zero product property because x minus 3 times 3x minus 1 has to give me 0. So if I multiply two things together and get 0, either this thing is 0 or this thing is 0. So we get x equals 3. Add 1. 3x equals 1, or we get x equals positive a third. Don't just box those answers in, because you have to check, did we exclude them? We excluded positive 1 and 0. Did I get those? No, so there are no extraneous solutions here. So sometimes these can involve a bit of work, because you're going to end up with a quadratic equation that you're going to have to solve. Number 4, solve this rational equation. So I need a factor of x plus 1 in the denominator everywhere. I don't like that 1 minus x. So I'm going to rewrite it as, I'm going to take out that factor of negative 1 and write it as x minus 1. That's a little bit nicer to deal with. And then, minus in that negative 1, I can make addition. Make this addition. So I took that negative 1, because there's a negative 1 sitting there, and got a positive 1. this is a little bit nicer to work with. So your common denominator is x plus 1 times x minus 1. So I have to throw out x cannot be 1 and x cannot be negative 1. You put that over 1 so everything's a fraction. The first term needs a factor of x minus 1. The second term needs a factor of x plus 1. And this term needs both, so x plus 1, x minus 1, over x plus 1, x minus 1. Now that I have a common denominator, I equate the numerators. I just deal with the numerators. 3 times x minus 1 plus 2 times x plus 1 equals x plus 1 times x minus 1. So I'm going to distribute 3x minus 3 plus 2x plus 2 equals, you could go through and multiply that, but hopefully you realize that's the difference of perfect squares, so that's x squared minus 1. It's a quadratic, so it needs to be set equal to 0. So I'm going to combine like terms first. It's a quadratic equation. I don't know why I put an extra equal sign there. So it needs to be set equal to 0. I like positive x squared, so I'm going to move everything over. So I get 0 equals x squared minus 5x plus 1 plus 1 plus 0. This needs to be factored. I'm going to take out the GCF of x. Now that it's factored, I can use the zero product property. I can say that thing is 0 or that thing is 0. So my solutions are x equals 0 and x equals 5. Do I have to throw any of them out? Nope, I have no extraneous solutions here, so those are my two solutions. Number 5, 4x divided by x minus 3 minus 2 equals 12 over x minus 3. So the first thing I want to do here is figure out what's my common denominator. That happens to be x minus 3 is the common denominator. Because that has a factor of x minus 3, that doesn't, but that has a factor of x minus 3. So, what value do I need to throw out is the first question I always need to think of. What value can I plug into the denominator to get 0, so x cannot equal 3? Well, that has the common denominator already. Minus 2 over 1, so that needs x, a factor of x minus 3, equals 12 over x minus 3. So now that I have the common denominator, I equate the numerators. 4x minus 2 times x minus 3 equals 12. You're going to distribute a negative 2, make sure you're distributing a negative 2. And you get 4x minus 2x plus 6 equals 12. This is a nice linear equation. 2x plus 6 equals 12. 2x equals 6, and you get x equals 3. So x equals 3 is the solution to this equation. But hopefully that warning light is going off in your head that up here we said x cannot be 3, because if I take x equals 3 and plug it in, you end up dividing by 0. So we have to reject this solution because it's extraneous. It's an extraneous solution. Where did we introduce that extraneous solution? We introduced it right here by multiplying by x minus 3 over x minus 3. It's 1 everywhere except where x equals 3. So by multiplying by that fancy form of 1, we introduce the possibility of getting extraneous solutions. This case, we happen to get one. It doesn't always happen, but that's why we need to check. So if that's not the solution, there are no solutions to this equation. So there are no solutions to this equation. Because x equals 3 is extraneous. Number 6, 4 divided by y plus 2 equals 1 minus 8 over y squared plus 2y. So the first thing I want to do is I want to factor the denominators. I'm going to factor out a y there and be left with y plus 2. So my common denominator is y times y plus 2. Let's figure out what values I need to throw out. Y cannot be 0, because that would cause this denominator to be 0, and y cannot be negative 2, because that will cause both of those to be 0. That denominator will never be 0, so those are the only two I need to exclude. So now let's get our common denominator. This first expression is missing a factor of y. This expression is missing both factors, so let's multiply that by y times y plus 2 over y times y plus 2. And then this expression is missing nothing in the denominator. So now that I have a common denominator, I equate the numerators. 4y equals y times y plus 2 minus 8. I'm going to distribute y squared plus 2y minus 8. Let's subtract the 4y over, because to solve a quadratic equation, it needs to be set equal to 0. Y squared minus 2y minus 8. That's a trinomial that needs to be factored. Do y minus 4, y plus 2. Apply the zero product property and get y minus 4 equals 0, or y plus 2 equals 0. We get y equals 4, and we get y equals negative 2. But a little warning light should be going off in your head, because back at the beginning of your paper, you wrote y cannot equal negative 2. Well, we got y equals negative 2 as a solution, so we call this a solution extraneous. This is an extraneous solution. If I try to plug in y equals negative 2, that would cause me to divide by 0, so it's not in the solution set. So we reject that solution, and our only solution is y equals 4.